The first question says, how many electrons are in the ion F? Now, the F here is the symbol for fluorine. So that means how many electrons are in the fluoride ion? You can see we're given the fluorine atom. The number below here is your atomic number. And now the number above is your mass number. Now there's something you need to know. Now the first thing is that your atomic number is equal to the number of protons. You see, we said initially that this is your atomic number. Now, if this is your atomic number, that means this number also tells us the number of protons that are present in this element. Now, we're asked how many electrons are in the ion F. Now, you'll see that this ion has no charge. There's no charge above here. For a neutral ion, the number of protons is equal to the number of electrons. The number of protons is equal to the number of electrons. Now, if the number of protons for a neutral atom or neutral ion is equal to the number of electrons, it therefore means the number of electrons is equal to the atomic number. And what is the atomic number? 9. And therefore, the electrons that are present in this ion is what? 9 electrons. To question number 2, it says, what is the mass number of an element if its atom contains 10 protons, 10 electrons, and 12 neutrons? What is the mass number of an element if its atom contains 10 protons, 10 electrons, and 12 neutrons? Now, there's another concept you need to grasp, which is that your mass number, which we will denote as A, is equal to the number of protons plus the number of neutrons. The number of protons plus the number of neutrons. Now, how many protons do we have here? 10. How many neutrons do we have here? 12. Now, 10 plus 12 would give me what? 22. And that's why the mass number of this element is 22. Now, to the third question, it says, 14.8 gram of a salt dissolved in 250 centimeter cube of distilled water. It gives a concentration of 0.8 mole per dm cube. Calculate the molar mass of the salt. Repeat myself again. 14.8 gram of a salt dissolved in 250 centimeter cube of distilled water. It gives a concentration of 0.8 mole per dm cube. Calculate the molar mass of the salt. Now, in order to do this, let us first understand what concentration means. Now, concentration, basically, let's say we are dealing with a Gary sample now, or we have a Gary solution, which composes of our Gary molecules and water. Now, if you're a Nigerian, you're familiar with this. Basically, Gary is made up of cassava. If you don't know what Gary means, but it's made up of cassava, So that Gary, let's assume that each particle of that Gary is dissolved in water. Now, that Gary is dissolved in water, or we can also use the salt also. Now, that salt is dissolved in water. Now, as the salt is dissolved in water, let me be making diagrams of this. As the salt, let's assume this is our salt. As the salt is dissolved in water, now when we add this salt inside this water, when the number of, let's say these are moles, when the number of particles or moles of this salt is greater than that of the water, we say that this solution is concentrated. That is, when the moles of each of these salt particle is greater than that of the water, we say that this salt is concentrated. Now, based on this, you would now see that concentration is dependent upon the number of moles of the salt. And that is why the formula for concentration is equal to the number of moles divided by volume. That is, if you increase the concentration, or if you want to increase the concentration, you therefore have to increase the number of moles of the salt. Now, based on this, if we want to make number of moles subject of the formula, you see the number of moles is equal to concentration times volume. Let us keep this as one of our equations. Now, coming to this place, we are asked to calculate the molar mass of the salt, not the number of moles. Yes, number of moles is equal to mass all over your relative molecular mass when you are dealing with a compound, or you can say your molar mass. So your relative molecular mass or your molar mass. So molar mass instead. We're using molar mass in this case. Now, this is our equation number 2, but we are looking for the molar mass, not the number of moles. So from here, let us make molar mass the subject of the formula. You would see that when we cross multiply, we would have number of moles times the molar mass, which is equal to the mass. If you divide both sides by n, you would see that the molar mass is equal to mass all over number of moles, and this is our equation number 2. Now, since we have this, we can now go and look at our parameters that we have. Now we're given a mass of 14.8 grams. So let's come here. We're given a mass of 14.8 grams. We're given that it was dissolved in 250 centimeter cube of distilled water. That means the volume is equal to 250 centimeter cube. And what else were we given? We're given a concentration of 0.80 mole per dm cube. So we give our concentration to be 0.80 mole per dm cube. Mole per dm cube. You can do this where you can write dm raised to the power of -3 per cubic meter. Good. So now you would notice that we are going to multiply this using equation 1, but you see that the volume here are different. Here is in centimeter cube, here is in dm cube. It is much easier for us to just convert here to dm cube. Now to convert to dm cube, basically, note that 1 decimeter cube, is equal to 1,000 centimeter cube. Now, we want to know how many decimeter cube are in 250 centimeter cube. Based on this, if you cross multiply, you would have 1,000 times x, which is equal to 250 times 1, which is 250. If you divide both sides by 1,000, divide here by 1,000, you would see that x is equal to 0.25 dm cube. Now I'm not going to open another page. Let us keep solving it here so that we would have all our details on one side. Now, we have this. We can just basically calculate the number of moles. Number of moles will be equal to what is our concentration, 0.80, and what is our volume, which is what, 0.25. Based on this, the number of moles will be 0.2 moles. Now, since we know our number of moles, we can go into equation number 2 to calculate the molar mass. Now, for the molar mass, it will be equal to, what is our mass? We're given a mass of 14.8 gram. So 14.8 divided by 0.2, and therefore our molar mass is equal to what? Molar mass is equal to 74 gram per mole, and that is the molar mass because the unit of molar mass is gram per mole, so 74 gram per mole. Now question number 4 says, how many atoms are there in 1 mole of hydrogen gas? How many atoms are there in 1 mole of hydrogen gas? Now we have an Avogadro's constant, which is symbol is N subscript A. It's equal to 6.02 times 10 raised to the power of 23 moles. Now, instead of just going directly into the formula, let us explain what mole means. Now, take for instance, I ask you to give me a dozen eggs. Now, if I ask you to give me a dozen eggs, it means give me 12 pieces of eggs, or give me 12 eggs. So, if I ask you to give me a dozen of books, it means give me 12 pieces of books. Now in chemistry, if I ask you to give me a mole of a substance or of an element, it means give me 6.02 times 10 to the power of 23 particles of that element. So if I ask you, give me, for instance, give me 1 mole of hydrogen gas. It means give me 6.02 times 10 to the power of 23 particles, or you can particles of hydrogen gas. If I tell you give me 1 mole of sodium, it means 6.02 times 10 to the power of 23 particles of sodium. Now, in this case, the number of moles has a formula. The number of moles has a formula which is equal to the number of atoms, or you can say the number of particles, or you can say the number of molecules divided by 6.02 times 10 raised to the power of 23. Now, we're asked to find what they say, how many atoms. That means the number of atoms are there in 1 mole of hydrogen gas. Now, how many moles were we given? 1. The number of atoms, let's write it here, number of atoms divided by 6.02 times 10 to the power of 23. And when you cross multiply, you would see that the number of atoms is equal to 6.02 times 10 to the power of 23 atoms. So 6.02 times 10 to the power of 23 atoms make up 1 mole of hydrogen gas. Now the next question says, what is the percentage by mass of sodium in sodium hydroxide? What is the percentage by mass of sodium in sodium hydroxide? Now, to find the percentage by mass of an element in a compound, basically what you do is we would have to find, first of all, sodium hydroxide has a formula, NaOH. Now, we would have to find the relative molecular mass of sodium hydroxide. Then from there, we can get the percentage by mass. Now, to get this, to find the relative molecular mass, what we would have to do is, how many atoms of sodium do we have here? 1. So say 1 times the relative atomic mass of sodium, which was given here to be 23. So 1 times 23. Plus, how many atoms of oxygen do we have here? 1. So we have 1 times, what is the relative atomic mass of oxygen? 16. So 1 times 16. And plus 1 times how many atoms of hydrogen? 1. So 1 times what is the relative atomic mass of hydrogen? 1. So we'll say 1 times 1. Now when we do this, we have 23 plus 16 plus 1, which is equal to what? 40. Now relative molecular mass has no unit, so 40. Now, to find the percentage by mass of sodium, to be equal to whatever you did here when finding the relative molecular mass, just pick it up. So 1 times 23 all over relative molecular mass 40. Now, since we're finding it in percentage, times 100. Now, this will be equal to 23 over 40 times 100. And now this will give us an answer of, 57.5%. Now, this is the percentage by mass of sodium. Hit the follow button, hit the like button, share to your friends. I'll see you in the next video.